Yeah, welcome to our discussion today. Today we are taking simultaneous equations by elimination method. Simultaneous equation by elimination method. So our learning objectives are to understand the concept of simultaneous equations, learn the elimination methods, apply the method to solve some problems, and check the solution by substitution if they are correct. So if we are asked, what are simultaneous equations? What are simultaneous equations? Simultaneous equations are a system of equation with two or more equations, with two or more unknowns. Simply, they are made up of two or more equations with two or more unknowns. So what do you have to do? You have to solve the equations to arrive at the value. Like the equations that we have here, this is equation 1 and this is equation 2. So you can see these are two equations with two unknowns. In this case, x and y are not known. So what are we going to do to obtain the value of x and y such that equation 1 will be satisfied and equation 2 will also be satisfied? What do we mean by that? Upon substituting a certain value for x and that of y, equation 1 should be true and equation 2 should be true. That is, what we have on the left hand side should be equal to what we have on the right hand side. Same applicable to the second equation. So what is solution? What do you understand as a solution? The solution is the point where the equations intersect. The solutions is the point where the equations intersect. So the solution of equation refers to that point where the equation intersect. If you look at it from a graphical point of view, the y-axis and the x-axis, they meet at a point solving the given line or equation. So you may be asked, what is elimination method? When simultaneous equations are given to be solved, you can solve it by elimination method, substitution method, or graphical method. You can also solve it from matrix point of view. So our discussion today is on how we can solve it using elimination method. So simply, elimination method is a method for solving simultaneous equations. Here, one variable is eliminated by adding or subtracting the equations. One variable is eliminated by adding or subtracting the equations. You will see how we will do it in one of our examples. So the goal is to make coefficients of one variable the same or opposite. The goal is to make coefficients of one variable the same or opposites. So this is an example. You can see this first equation. Equation 1, we have x plus y equals 10. And equation 2, we have x minus y equals 2. So in this case, if we add both equations, that is equation 1 and equation 2, what you will have is this. This is x plus y plus x minus y is equals to 10 plus 2. So clearly you can see x plus y plus x minus y is equals to 10 plus 2. So at this point, we open this bracket and collect like terms. By doing so, we will have 2x is equals to 12. You can see x plus x implies 2x is 2x and y minus y is 0. So that's why you are not seeing y here again. While 10 plus 2 equals 12. So this implies x is equals to 6. How? You see, you divide both sides by 2. You divide here by 2. You divide here by 2. Your result will be x equals 6. X equals 6. So now we will substitute x equals to 6 in equation 1 or equation 2. You can substitute it in any of these equations. It's supposed to arrive at the correct answer. So by substitution, so where we see x, we will put 6 in equation 1. So this gives us 6 plus y equals 10, which implies y equals to 4. Simply, you can see you transfer 6 to your right hand side. That will be y equals 10 minus 6, and that will be equals to 4. Or you add minus 6 to both sides, you will still arrive at this result. So the answer here is x equals to 6 and y equals to 4. So this equation, this simultaneous equation, the solution to the unknown variables, the x and y, is given. And this is the outcome. X equals 6 and y equals to 4. Another example, equation 1 is given. 2x plus 3y equals 17. Equation 2 says 4x minus 3y equals 1. Clearly, you can see we have plus 3y and we have minus 3y. So if we add this place will be 0. There will be no y again. So this helps us to move straight by adding equation 1 to equation 2 and correlating our like terms. So 2x plus 3y plus 4x minus 3y, so this is what we have here, is equals to, so at this point you add and collect your terms. So clearly we have 17 plus 1 is 18. So when you do that, when you simplify this by addition, like collecting like terms, we have 2x plus 4x is equals to 6x and 3y minus 3y equals to 0. That's why we are not having it here again. And 18 is equals to 18. So that's why we are having 18 here. So when you divide both sides by 6, divide 6x equals to 18. When you divide by 3, divide 6 here, we have x. And you divide 18, we'll have 3. So the result is now x equals to 3. That is by dividing both sides by 6. So when you substitute this value, the value for x into your first equation. Remember, in this equation, we have 2x plus 3y equals to 17. When you substitute your value into your first equation, this is what you will have. It looks in this form. 2 multiplying 3 plus 3y equals to 17. You simplify this and make y the subject of the formula. You have 11 divided by 3. 11 divided by 3. So, y equals 11 divided by 3. You just follow the same step as we did earlier for the other example. And make y the subject of the formula. You arrive at this point. So the answer here is 3x, y equals 11 divided by 3. Now, let's consider example with multiplication for elimination. This is another example with multiplication for elimination. So this is equation 1, equation 2. These are two simultaneous equations given to be solved. So we multiply equation 1 by 2. Why? We are looking at how we can make addition or subtraction such that one unknown will be eliminated, such that when we add equation 1 and equation 2, the result should be either this is 0 or the y here is 0. It's eliminated. So in this sense, if we multiply equation 1 by 2, here we will have 2x and 2x. So when we subtract equation 1 from 2, we will have that 0 here. So that's where we are going to. So we multiply equation 1 by 2. So we will have 2x plus 4y equals 10. 2x plus 4y equals 10. Multiply by 2, we'll see it, equation 1. 2x times 2 times 2, 4y times 2, 10. So that is why we're having this. So thereafter, we are now using this as our equation 1 and add it to equation 2 and subtract it to equation 2 rather. So equation 2 subtracts equation 1. Equation 2 minus equation 1. This is what is happening here. Equation 2 minus equation 1. So what we are using here is a new multiplication we had here. So this is now another equation. Another learner can name it equation 3. So we subtract equation 2 by using equation 3. So we subtract equation 3 from 2. So this is now 2x plus 3y minus 2x plus 4y equals minus y equals minus 2. Is it so? You can see 2x minus 2x is 0. That's why you are not seeing it here appearing. Then this one is now 3y minus 4y. 3y minus 4y is now giving us minus 3y minus 4y is now giving us minus y. You can see it's giving us minus y. 3y minus 4y is giving us minus y. So the result now is given here. You can do it yourself. 2x minus 2x is 0. Now 3y minus 4y is minus y. Remember, we had 10 here and we had 8 here. So when you subtract 8 minus 10, it will give you minus 2. 8 minus 10 to give you minus 2. So minus cancel minus. We now have y equals to 2. So you substitute x plus 4 equals to 5. When you substitute, we have x plus 4 equals to 5, implies You solve for x. X is equals to 1. You know how to solve for x. You solve for x. So x equals to 1. So x equals to 1 and y equals to 2. You know, this substitution is done using equation 1. You too, you can try it using equation 2. Substitute the given value of y into equation 2 and see what you will have. So substituting it in 1 make it faster and simpler for us. So we have this. So I'm solving for x. You know how to solve for x now. So x plus 4 equals to 5. So when you transfer 4 to this other side of the equality, we will now have a negative sign, which gives us 5 minus 4. So 5 minus 4 equals 1. So that is how we have arrived at x equals to 1. And this is the result by method of elimination. We have a practice problem here for you. You can try this yourself. This is what is given. Equation 1, equation 2. What is the hint? You add the equations. Add the equations component-wise. When you add this 3x plus 2x, you have your result, which is 5x. You add this 2y plus minus 2y. It goes, that is 0. Then you add this side, you now have 16 plus 4 equals 20. So let's see. So that is what we were discussing. We have just discussed this line. So we arrive at this point, 5x equals to 20. So you solve for x by dividing both sides by 5. You will have x equals 4. X equals 4. So you see this is adding equation 1 and equation 2. So you arrive at this as I explained earlier. So upon substitution, you substitute your value. You substitute your value, x equals to 4, into the equation. Like in this case, it was substituted into equation 1. As you can see, substituted into equation 1. So you substitute it into equation 1. Anywhere you see x, you put 4. So you solve, simplify, solve, and arrive at y equals to 2. So the value, the result for that simultaneous equation is x equals to 4 and y equals 2. So in our discussion, there are things you should learn from the examples we have just considered. The first thing is that when solving for simultaneous equation by method of elimination, you should arrange both equations in standard form. You should arrange both equations in standard form. By the standard form, we also mean that x should be correlated to one side and y to one side, then equality sign, then the constant. So if x is taking your left hand side, so x plus y, the y term follows by equality sign, then follows by the constant term. So the constant comes after the equality sign. So you arrange your equations in standard form, and they should be uniform. Once they are in uniform, like your equation 1, x is coming first, followed by y. Equation 2 should be the same. X should come first, followed by y. Then you have equality sign. What should follows the equality sign should be constant. A constant should be there. So, step 2, make coefficients of one variable equals or opposites. Make coefficients of one variable equal or opposite. Recall how we did. In our example, we force the coefficient of one of the equation, which was equation 1, we force the coefficient to be equal to the coefficient of equation 2 by multiplying equation 1 by that constant. In our case, we multiply equation 1 by 2 all through before we were able to add. So make coefficients of one variable equal or opposites. The next thing you should do is to add or subtract to eliminate one of the variables. As we did, we added, and in the other example, we subtract. This helps us to eliminate one of the variables. We were able to eliminate y in our case, and we use the result obtained from x to solve for y. So solve for the remaining variable. The next step, we solve for the remaining variable. Thereafter, we substituted our result to the given equations to find the other variable. We substituted our results in the given equations, one of them, in one of the equations, to find the other variable. One of the easiest method is for you to look into the two equations, the given equation, which one is simpler. Use that one to conduct your substitution. Next, you check if your result is correct. You check if your solution is correct. So if what you have on your left-hand side of the equation equals what you have on your right-hand side, it means it is correct for equation 1. You have to test that of equation 2 as well. If what you have, the summary of what you have on your left-hand side equals what you have on your right-hand side. So thank you for participating in our class today. You have learned how to solve equations using the elimination method. Keep practicing to master it. So if you have any question in regards to our discussion today, you are free to drop your question in the comment section. If you need any topic to be treated, you're also free to mention it in the comment section. So if you have some other problems you want us to solve, you're also free to do so. Check our post. We have other teachings in mathematics. You are free to go through those videos and see if there is anyone you have challenged. Then you can learn from us. Thank you till I come your way again.